Welcome back to another video. Today we're going to master a fundamental algebra skill, solving systems of equations. A system is just a collection of equations working together, and finding the solution is like solving a puzzle where all the pieces have to fit perfectly. To do this, we're going to break down the three core methods you absolutely need to know: graphing, substitution, and elimination. By the end of this video, you'll know exactly when to use each strategy so you can tackle any algebra problem with total confidence. First off, what actually is a system of equations? To simply put it, it's just a set of two or more equations that share the exact same variables. For example, if we take a look at it visually on a graph, the solution is the magic point where the lines cross. It's the single coordinate pair that makes both equations true at the exact same time. For example, in this graph shown above, it's right here at the intersection point 2, 5. Next, we'll dive into our very first method, solving by graphing. We start by plotting our first line, which is color-coded here in yellow. Notice that it has a y-intercept at +1 on the vertical axis. Next, we'll layer our second line right on top of the same grid, which is shown here in green. The line starts a bit higher, at a y-intercept of +4. Now take a close look at the exact spot where these two paths cross on your screen. They intersect perfectly at the unique coordinate point 1, 3. Because this single point lies on both lines simultaneously, it satisfies both equations at the exact same time. Now, let's try a quick practice problem together. We want to solve the system y equals -x plus 3 and y equals 1/3 x plus 1. To begin, we start out by setting up our coordinate plane. First, we plot the line with a y-intercept of 3 and a downward slope. Then we plot the fractional line starting at 1 and rising slowly. Because of the fraction, they don't meet perfectly on an integer grid line this time. They cross right in the middle at 1.5, 1.5. Graphing is great for a visual check, but when answers are decimals, it can be tricky to read perfectly. And that's exactly why we have algebraic methods like substitution. Substitution is perfect when it's hard to read a graph, or when one of your variables is already isolated. The steps are straightforward. Isolate a variable, stuff that expression into the other equation, solve for the remaining letter, and then finally, plug that value back in to find your missing coordinate. This method is incredibly powerful because it turns a complex two-variable problem to a basic single-variable equation that you already know how to solve. The strategy is your absolute best option whenever you see an equation starting with a clean y equals or x equals. Now, let's see it in action with practice problem 2. We have y equals 3x and x plus y equals 8. Notice how the first equation already tells us exactly what y equals. It equals 3x. So we can substitute or plug in 3x straight into the second equation wherever we see a y. That gives us x plus 3x equals 8. Then combining like terms, we get 4x equals 8. Then x, we can simplify that to x equals 2. And now we're halfway there. Just plug that 2 back into our original simple equation, y equals 3 times 2. And finally, we get y equals 6. Written as a coordinate point, our final solution is now 2, 6. Notice how easy that was? Well, as long as you remember your basic algebra, you'll be fine. Our third and final method is elimination. To master this technique, you just need to follow 4 clear steps. Step 1. Line up your equations vertically so the x variables, y variables, and constants form neat columns. 2. Look closely at the coefficients to see if adding the columns together will eliminate a letter. 3. Add the two equations straight down to cancel out one variable. Finally, 4. Take that numeric answer and plug it back into either of your original equations to calculate the final missing coordinate value. Just remember, if the coefficients aren't opposites yet, you might need to multiply one of the equations first to force a cancellation. Now that we've learned how to do elimination, let's try a practice problem. Say we have the equations 5x plus 2y equals 12 and 3x minus 2y equals 4. Do we see how the x's and y's are perfectly lined up? And even better, we have a positive 2y and a negative 2y. They are perfect opposites. Now when we add them straight down, they cancel out. 5x plus 3 gives us 8x, and 12 plus 4 gives us 16. So 8x equals 16, and then dividing by 8 on both sides, x equals 2. To finish up, pick either original equation to find y. Let's use the top one. Plug in 2 for x, that's 5 times 2, which is 10. So 10 plus 2y equals 12. Subtract 10 from both sides, and you get 2y equals 2, which is also y equals 1. Therefore, our answer in point form is 2, 1, meaning the two equations would intersect at x equals 2 and y equals 1. Now we have to remember that math isn't just numbers on a page. This actually matters in the real world. Imagine you run a bakery. Cookies are $2 each, cupcakes are $4 each, and you sold a total of 10 items and made $26. How many of each did you sell? Let's turn this into a system. Let C be cookies and P be cupcakes. Our item total gives us C plus P equals 10. Our revenue gives us 2C plus 4P equals 26. By using any of the methods we just learned, you can solve this system to discover you sold exactly 7 cookies and 3 cupcakes. Before we wrap up, let's look at a quick challenge problem involving a special case. Y equals 2x plus 4 and negative 4x plus 2y equals 8. How many solutions do you think this has? 1, 0, or maybe infinite? Pause the video and make a guess. To start, let's rewrite the second equation into standard form, which is slope-intercept form. We start by isolating y, and if we add 4x to both sides, we get 2y equals 4x plus 8. Then divide everything by 2, and would you look at that, it simplifies to y equals 2x plus 4. Both equations are actually the same exact line. Because they lie right on top of each other, they intersect at every single point. This means that our given system actually has an infinite amount of solutions. Finally, to give you a quick recap and conclusion, make sure to use graphing for a quick visual solution, substitution when a variable is already isolated, and elimination when everything is lined up in standard form. Keep practicing these steps, and solving systems of equations will become second nature in no time. If this video helped you out, make sure to hit that like button and subscribe for more math guides. See you next time, and thank you for watching.